For question 5, this is the one with someone throwing a stone in the air. The idea here is that the whole time the ball's in the air, it's accelerating down. So for the first two parts, part A and part B, I think you said you did that already, right? Well, for those two parts, I would say you use the information for the whole trip. So here's the information that you can put in. You know that the displacement is negative. I'm saying here to pay attention to the signs because the displacement is negative. Even though it goes up and comes down, it ends up 82 meters below where it started. So that's where the negative 82 comes from. The positive is because you initially throw it up. It's got a velocity of positive 10 VO, and then its acceleration is negative 9.8 because the acceleration is always down. So the idea here is that you use this information to find the other two variables. Now for part C, it's asking for the total distance, which means you really need to know how far does it go up and then how far does it come down. We know this part is 82. Oops, 82 meters, 82 meters, right? So what we need to figure out is the x on the way up. That's the question you were asking me. How far up does it go? Okay, so looking at it, when you think about up, from when the ball leaves her hand to the highest point, what we're saying here is that when it leaves her hand, it's going 10 meters per second up. So that's what the positive is for. And then at the very highest point, I've got it highlighted in pink. It's not. It's like instantaneously at rest. So we do have these three pieces of information here. We see here its velocity, initial velocity is 10 up. Its final velocity at the very top is 0 for an instant, and its acceleration is negative 9. So using those three pieces of information and time being you don't know, don't care, you can find delta x. It would be like you would use this equation, which is v squared equals v naught squared plus 2a delta x, and then solve for delta x. That would tell you how far up it goes. Now, how far down it goes is basically the same amount, right? Because it's going to go from there, it's going to go here. That's also the same number, and then you just have to add 82 to that. So the down part of it I'm showing here is basically you're going to take that 82 plus the whatever you got up, and then you make it negative because that's how far down it goes. So you've got the delta x. You know that at the maximum. So now we're talking about the down part, which starts at 0 and goes, well, at the highest point, the velocity is 0. So now we're taking the highest point to be the initial position. And so that would be 0. It's still 9.8. So in this example, your v is going to be your don't know, don't care. You're going to find, let's see. Oh, actually, you don't even need to do anything here. As long as you know the up, this is totally unnecessary. As soon as you know the answer for the up part, you can just plug it in over here and then add it all together, and that should give you the answer. Okay? I hope that helps.